Very quick one, guys. When we say filtration, the big question is, what is filtration? What should come into our mind when we're looking at filtration? Of course, this is our lesson 2, right? Yeah, let's go together. First and foremost, when we say filtration, you must know the definition of filtration. Very simple. Tell us this, that filtration is used to separate a solid. Listen, before we even move, don't cram. Understand. Understanding is superior to cramming. Just understand the procedure behind those things, and then you are flowing with me. Filtration is used to separate a solid, right, that is insoluble in a liquid. Pause there first. What is filtration? Filtration is used to separate a solid that is insoluble in a what? A liquid. In other words, for filtration to be used, you must ensure that the solid is insoluble in the liquid. In other words, an insoluble solid can be separated from a liquid by what? Filtration. So, which method do we use to separate insoluble solid from a liquid? Filtration. What is filtration? Filtration is used to separate a solid that is insoluble in a what? In a liquid. So the solid must be insoluble in the what? In the liquid. So that's why we use what? Filtration. And don't forget this, that filtration methods, they rely on two major things. Past question, Waec question, Jamb question. What are the two things that filtration rely on? Number one is called the differences in their physical states. That's why we said that filtration is used to separate a solid from a solid that is insoluble in a what? In a liquid. So solid and liquid, what is their states? Are they in the same physical state or different physical states? Different physical states. In other words, filtration method rely on two things. Number one is called differences in their physical state. So one must be solid, the other one must be what? Liquid. And that solid must be insoluble in the liquid, meaning it will not dissolve in the liquid. And the second thing that you rely on is called the insolubility of one component in the other. In other words, one component must be insoluble in the other. So what is filtration? Filtration is used to separate a solid that is insoluble in a liquid. In other words, the insoluble solid is separated from the liquid by what? Filtration. And filtration will rely on two things. Number one, differences in their physical state, where one is solid, the other is liquid. And number two, insolubility of one component in the other, where the solid is insoluble in the what? Liquid. If you get this, come out, you're too good. Now let's rub this together. Now the big question is, what are the examples of mixtures separated by filtration? Of course, I'll give you 3 of them. Number one is called suspended particles in a liquid. A good example, your mud water. If you watch your mud water, right, the mud itself, is it soluble in the liquid? No, it's not soluble in the liquid. It will not dissolve. Sugar is soluble in water. So you cannot go and separate sugar and water by filtration. It will never work. Salt is soluble in water because salt will dissolve in water. Mud water does not dissolve in water. Mud does not dissolve in water. Carry the mud and the water, shake it together, leave it, give it time, right? After a while, what will happen? You will see that the mud will come down. It will float downwards, meaning it does not what? It is insoluble. That's what it means basically. Please, in your filtration, we have established the procedures involved. And a good example is suspended particles in what? In liquid. That's your what? Your mud water. Number 2 is called sediments in water. Sediments, where you have like different layers, right? And then number 3 is called a saturated solution with undissolved solid. Saturated solution that has what? Undissolved solid. Now let me show you something very interesting. What is the procedure? The procedure we employ in your filtration is simple, and it as follows. Number 1, insert a cone-shaped filter paper into a filter funnel. First, this guy here is called your filter funnel. And this guy is your cone-shaped filter paper. How do I obtain my cone-shaped filter paper? First, carry your filter paper. This is how filter paper look like in size, like circular. Fold it into two. It will give you like semicircle, right? Now, that one semicircle, go ahead and fold it again into two. It will now give you something that looks like this, something that looks like this, which is like a cone. And then you now open the middle of it. You are going to get something of this nature exactly. Carry this cone-shaped filter paper and put it inside the funnel. That's why we say insert the cone-shaped filter paper into a filter funnel. Are you seeing it now? Number 2 procedure is pour the mixture into the filter funnel and let it drain. The entire mixture that you have, pour it into the filter funnel, let it drain. Maybe it's mud, water, or whatever, pour it inside. And then step 3, the liquid. If you pour it inside the filter funnel, what will happen? The liquid will go down. You can now collect it in your receiver, right? That liquid that goes down is called the filtrate. What is it called? Filtrate. So the filtrate will pass through the pores of the filter paper and you can collect it in a receiver. The one that goes down is called the filtrate. The one that remains in that filter paper, what is it called? It is called the residue. The one that does not go down is called the residue. The one that goes down is called the what? The filtrate. So the solid residue will remain on the filter paper. Now, follow me. Let me explain. Look at this very quickly. Can I give you like the experiment so that you understand it? Very simple. Your filtration experiment. In filtration experiment is very simple. Now, all you have to do is you have done your setup. You are going to have something of this nature. Carry your beaker that contains all the entire mud water, pour it inside your filter paper. As you pour it, you see what is coming down now. What do you call this? This is your filtrate, right? So what you have there is your filtrate, and that is the liquid only that we go through. So the filter paper that you have inserted inside the filter funnel, what will happen? It will hold the other particles that will not go down. That's the liquid and the solid mixed together. Those that refuse to go down, what do you call them? They are called residue. What is it called? Residue. So your residue is different from your filtrates. Now let's say this is the beaker. This guy here is the beaker that contains the entire mud water, right? And you have poured the mud water into the filter paper. And then what happened? You are going to receive number 1, filtrate, liquid only. And number 2, residue. What is the residue? The liquid and the solid mixed together. Is it making sense? So this is how your filtration experiments look like. Very easy and direct. To get this very quickly, I'd like you to note this very fast. You must understand that when using filtration, the pure component we want is the residue. And that residue is what is left on the what? The filter paper. Probably you don't want the filtrates, meaning the liquid component that go down, as the case may be. It just depends on exactly what you want. If you get this very fast with me, what is the application of your filtration? What is the application? It's very simple. The application of filtration include the following. Number 1 is called domestic filters. What is it called? Domestic filters. So filtration, we apply it in your domestic filters, and by that we use it at home to filter your drinking water. Just imagine some cities, let me say like in Nigeria, that don't have good water, like your Lagos, for example, or other major cities that water is dirty. Of course, you need these domestic filters at home, right, to filter your drinking water. And of course, these filters have upper layer that is made up of filter candle. Listen carefully. They have 2 layers. Number 1 is called the upper layer. In that upper layer, what do we have there? It has filter candle. And the lower layer that is used for storing filtered water. So the upper layer has what? Filter candle, right? And the lower layer is used for storing what? Filtered water. I'm going to show it to you very shortly. And don't forget this very quickly, that the boiled water is poured into the upper layer, right? That boiled water that is impure, you pour it into the upper layer and it will pass through the filter candle, and the filter candle will filter the water and then it is now stored in the lower layer where you can now receive it through your tap. And of course, don't forget this, that sediment will remain in the upper layer. Now follow me, let me show you the procedure. We have said that domestic filters has how many layers? 2 layers, very quickly, right? Okay, of course, this is how your domestic filter look like. This guy here is the first layer, and this guy here is the second layer. You can see in this, in the entire setup, first, you can see that this is the lid or the cover. So aside the lid or the cover, we have what is called the unfiltered water. Unfiltered water is in the first layer or second layer? First layer. And of course, in that first layer as well, you have what is called your filter candle. Because it is that filter candle that will carry out the entire filtration process. And then you now have your filtered water in the second layer. And of course, you have your tap. This is the entire procedural setup. So if they ask you to draw this structure in exam, your domestic filter water in WAEC, I'm sure you can draw it very, very quickly. It's very simple, easy, and direct. And you just label it. You can see your lid or your cover. You can see the unfiltered water. You can see the filter candle that will carry out the filtration. And you can see the filtered water. And then you can see your tap where you can open it and then you can collect your water. Very simple. And of course, aside domestic use, second application is called large-scale purification. Of course, in large-scale purification, how does it operate? It's very simple. What happens is that it involves a filter bed that is composed of various sizes of sand and pebbles to purify water for town supply. You see this normal water now that runs, all this normal water that is, I'm not talking about borehole, right? I'm talking about your normal water that that is being sent to various homes from like one location, right? Where the water is now used to the water is supplied to various homes. This is exactly the procedure, how they operate. It operates on 5 different layers. How many layers? 5. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. This is your first layer, layer 1, layer 2, layer 3, layer 4, and layer 5. And what happened in layer 1? Layer 1 is what contains what is called the unfiltered water. Unfiltered water. Probably you can, let me see people that like your normal, your pure water company, some of them can operate this procedure. Unfiltered layer is layer 1. But the pure water company is more sophisticated even than this. Your layer 2 is the one that contains what is called your fine sand. Unfiltered water, layer 1. Fine sand, layer 2. Layer 3 contains even something more mature than fine sand, and that is called your fine stones. Fine sand, layer 2. Fine stones, layer 3. Layer 4, you see that it's now bigger in size, and that is called your gravel. Gravel. And then layer 5 contains what is called your what? Your pebbles. How many layers do we have? 5 layers. Unfiltered water, layer 1. Layer 2 is fine sand. Fine stone, layer 3. Layer 4, gravel. Layer 5, pebbles. And then what happens? All this unfiltered water that you have here, they start to pass through all the other layers below, one after the other. And then filtration is carried out adequately and neatly until you have your pure water that you can now collect in the outlet. This is the outlet for filtered water. So your fine sand, your fine stone, your gravel, your pebbles, all of them will help in filtering the unfiltered water. At the end of the day, what you have is your filtered water. And this is what we use for industrial usage. Is it making sense? These are the advantages of your filtration. If you get this very quickly with me, that means you are doing extremely well. And guess what? It's time to rock past questions. Can we rock it together? Yeah, let's go. Look at your Jamb past questions very quickly. Don't fail anyone for me. In Jamb question, Jamb 1978 question 40. Jamb asks this beautiful question, and the question all the way says, by means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and means of filtration. In filtration, something should come into your mind. You need your liquid, right, which is the solvent, and you need your solute, which is insoluble in the solvent. Don't forget that. That's for filtration for you. Of course, option A say your potassium nitrate. Potassium nitrate can dissolve in water normally. Option B says sand. Sand will not dissolve. It is insoluble. Option C says lead nitrate. To some extent, it is soluble. Option D says sugar, which is glucose, it will dissolve. Option E says starch. It will also dissolve to some extent. What is the answer? The answer here is what? Your sand, option B. By means of filtration, one component can be obtained pure from an aqueous mixture. Aqueous means there is water there. Aqueous mixture of sodium chloride. And what? Of course, that sodium chloride will dissolve inside the water, right? But sand will not dissolve in it. Now, let me explain to you very fast. Understand this quickly, really, that filtration works best when separating a solid that does not dissolve in a liquid. In other words, the solid is insoluble in the what? In the solvent, which is the liquid, right? Very simple. And of course, don't forget is that sand does not dissolve in water. So it can be separated from an aqueous mixture by what? Filtration. Very simple. And of course, your sodium chloride, potassium nitrate, lead nitrate, sugar, and starch, all of these guys will dissolve in water to varying degrees, and thus cannot be separated from sodium chloride by simple filtration. No, you can't do that. Does it make sense now? You understand that? Let's look at Jamb 1994 question 1. 1994 question 1. Look at the beautiful question they asked. A mixture of sand, ammonium chloride, and sodium chloride is best separated by a mixture of sand, ammonium chloride. Ammonium chloride can be sublimed if you undergo sublimation. Sodium chloride will dissolve in water, but sand will not dissolve. How do you separate them? It can best be separated by A, sublimation, followed by addition of water and filtration. Option B says sublimation, followed by addition of water and evaporation. Option C says addition of water, followed by filtration and sublimation. Option D says addition of water, followed by crystallization and sublimation. What is the answer? Now listen. Your ammonium chloride that is there, you know there is sand, ammonium chloride, sodium chloride. Ammonium chloride that is there, you can sublime it, so that guy will go. So sublimation is the first step. After sublimation have occurred, I still have my sand and then my sodium chloride. Of course, what will I do? Add water. If I add water, sodium chloride will dissolve in the water. So addition of water is number 2. And then filtration is number 3. Because I can filter and then my sand will go out of it. What is the answer? Option A becomes the correct answer. Very simple. Sublimation followed by addition of water and filtration. Now listen carefully. By sublimation, what will happen? Ammonium chloride, which is your NH4Cl, what will happen to it? It can be separated from the mixture first by heating it. So as you heat it, what will happen? It will sublime. It will change directly from solid. Without passing through the liquid state, it will go to what? Your gaseous phase, and then it will leave at relatively low temperature compared to sand and sodium chloride. Step 2, addition of water. When you add water, what will happen? After removing ammonium chloride first, that one has gone, right? The remaining mixture that consists of sand and sodium chloride, what will happen? Sodium chloride will dissolve in water because it is soluble in water, but sand is not soluble. And step 3 is called filtration. By filtration there, add water to the mixture, will dissolve sodium chloride, leaving the sand undissolved, right? So filtration can be carried out to separate sand from the sodium chloride solution, because the sodium chloride solution that you have is sodium chloride and water. Does it make sense now? And then after that, the 3 steps are the things that you just use there very, very quickly and you are out of there. And what are the 3 steps? Number 1, sublimation to remove what? Ammonium chloride. Step 2, addition of water to dissolve what? Your sodium chloride. And then step 3, filtration to separate sand from sodium chloride what? Solution. And then you are out of there. If you get that very quickly with me, look at your JAMB 2009 question 1. The beautiful question here says a mixture of sugar and sulfur. Sugar and sulfur can be separated by, if you add water, sugar will dissolve in the water, sulfur will not dissolve. How do you separate it? A is a dissolution in water, evaporation and filtration. B says filtration, evaporation, dissolution in water. C says dissolution in water, filtration and evaporation. This is evaporation, dissolution in water, and what? Filtration. Now, what do you do there? First, just know that dissolution of water is what we start it so that sugar can dissolve. So B and D cannot be the answer. After dissolution of water, what will I do next? I've dissolved it in water. So your sugar have already dissolved in the water. The next thing to do is carry out filtration so that you can filter out your sulfur. Filtration. And then the next step is evaporation so that you can evaporate your water and get your sugar. Option C is the correct answer. Don't cram. Share you the feel. You the feel, Abi. Option C, dissolution in water, filtration, evaporation. How do we carry out that? Very, very simple, easy and direct. What you do there is dissolution in water. Sugar will dissolve in the water. Why sulfur will not dissolve? The next step is filtration. After dissolving the mixture in water, filter the mixture to separate the undissolved sulfur from the sugar solution. When you have done that, what happens next? Number 3, evaporation. Evaporate the water from the sugar solution to obtain the sugar alone. So you have separated the 3 of them. And of course, don't forget is that this process efficiently separates your sugar from the sulfur based on their different solubility in what? Water. Their differing solubility is what you have applied. Solution in water, filtration, and what? Evaporation. If you get this very quickly, that means you can rock the WAEC past questions. Oh yes. Are you good to go? Yeah, let's go. Look at WAEC past question, WAEC 2014 question 18. WAEC has this beautiful question. A compound U melts at 82 degrees Celsius and boils at 113 degrees Celsius. If U was found to be insoluble in water, filtration. A mixture of U in water can be best separated by, they have told that the U there, the substance U, is insoluble in water. Because it is insoluble in water, what do you use to separate in any solid that is insoluble in solvent? What do you use? Filtration is what you use. Option A say chromatography, no. Sublimation, no. Filtration, the use of separating from. What is the answer? Filtration is the correct answer. How is it filtration? It is filtration because we have enacted and established this from the question originally that since U is insoluble in water, it will not dissolve. And because it will not dissolve, it will remain as a solid in the mixture, which can easily be filtered by what? Filtration. That's what you apply there. Does it make sense? Now look at question 5, WAEC 1989, question 19. WAEC asks this question, the most suitable method to use when separating an insoluble solid that will not dissolve from a liquid. Baba, what is the answer? Evaporation, filtration, magnetization, sublimation. They have just given you the definition for what? Filtration, option B. Why? Because your filtration is the method that we use to separate a solid that is insoluble in a what? Liquid. And we say filtration operate on 2 parameters or rely on 2 methods. Number 1 is called the difference in their physical state. One should be solid, the other one should be liquid. And of course, the insolubility of one component in the other, we can play with it. That's why filtration is the perfect answer. If you get that very quickly, look at question 6, WAEC 1998, question 10. WAEC asks this question, a mixture of sodium chloride and CaCO3, calcium trioxocarbonate 4, solid, is best separated by option A, say dissolution followed by filtration. Of course, sodium chloride will dissolve in water. CaCO3 will not dissolve, and you can filter it. Option B say very quickly sublimation. No, nothing like sublimation there. No, that one does not even follow. Option C say dissolution followed by evaporation. Option D say dissolution followed by crystallization. What is the answer? Dissolution followed by what? Filtration. Option A is the correct answer. Right? Why is it so? It's very simple, easy and direct. It's so because your sodium chloride is soluble in water, but CaCO3, calcium trioxocarbonate 4, is not soluble in water. And of course, therefore, the best way to separate a mixture of sodium chloride and calcium triazocarbonate 4 is to dissolve it in water, right? When you dissolve it in water, what will happen? Sodium chloride will dissolve in the water, forming an aqueous solution of sodium chloride. But CaCO3 will not dissolve. It will remain as solid. And what will happen? Filtration can now be used to separate solid CaCO3 from your sodium chloride solution. And that's how you obtain it and you are out of there. If you understand this very quickly, look at question 6. WAEC 2001 question 16. WAEC adds this question. A mixture of calcium chloride and calcium trioxocarbonate in water. Calcium chloride, CaCl2, will dissolve in water. But your calcium triazocarbonate 4, CaCO3, it will never dissolve in water. How do you separate them? Option A is evaporation, sublimation, distillation. What is the answer? Filtration is the answer. You know why, right? Yes, very simple. Why is it so? It's because very fast. Calcium chloride is soluble in water, meaning it will dissolve in the water. When you mix it with water, it will dissolve. But your calcium triazocarbonate 4, CaCO3, on the other hand, will not dissolve because it is insoluble in water, making it to remain as a solid, which even if you mix it, it will still not dissolve in the water. And of course, what happens? Filtration technique is now used to separate a solid from a liquid in which it is suspended or insoluble. And don't forget that by filtering in the mixture, what will happen? The insoluble calcium triazocarbonate 4, CaCO3, will be trapped by the filter, that filter paper, right? While the soluble calcium chloride will pass through the filtrate, right? It will pass through as the filtrate, and then you can now receive it in the beaker. And that's just the procedure, and you're out of there. Guess what? If you understand this very quickly with me, in the next lesson, we are going to be looking at decantation. Very, very important. And I'll see you in the next class, and that is all about what? Decantation. I'll see you there. Bye-bye. Enjoy yourself. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.